So today in my class, I'm going to discuss a few more problems on hypothesis testing, and a few more cases will be discussed here. I hope that all of the students, those who are present right now in my class, today's class, they have gone through all the 4 videos in the YouTube. I have so far uploaded 4 videos in the YouTube about hypothesis testing. The last class with CSE section A, there I discussed about level of significance and confidence limit, and the relation between the two. Also, I can recall that I started one problem in our earlier session, and that problem actually was incomplete. And I told you that I'm going to finish that problem with you. Okay, so I didn't discuss that particular problem with CSE section B intentionally. With CSE section B, CSE section A. With CSE section A, I discussed some other problem, some other case. So my first duty is to finish the incomplete problem which I started in the previous session. First of all, that problem which I selected was the problem of pineapples, I think, and that problem actually, no, not pineapple. What was the problem? Can you tell me? I was I didn't get the chance to complete the problem. Which problem was it? Anybody can write in the chat box. At least remind me, because I have the questions with me, but I cannot recall the problem. If you can tell me at least one word from the problem or first line. One problem I can, I'm sure that that was left undone, or this was half done actually. Was this problem in a sample of 1,000 people in Maharashtra? Was it like that? Yeah, yes. 540 are rice eaters. Yeah, okay. Thank you so much. So that problem was incomplete, and so let me finish that particular problem. And can you tell me? Can you tell me what was the Z value? What was the Z value that we obtained in that particular problem? Anybody? Can you recall the Z value? $2.5316. Yes, okay, 2.5316. Thank you, Nasal Manit. So in that particular problem, if you can recall, the Z value came out to be 2.53. Approximately, this was the Z value. Now, as you have seen I hope you have seen my last 2 videos on level of significance and confidence limit. So right now we are in a position to draw the conclusion on the basis of the Z value that has been obtained in this particular problem. So I'm going to write all the steps here one after another. So step 1, we need to find out the absolute value, which is same over here because the value itself is positive. Step 2 is saying that mod Z is actually less than 3, and we need to go for further analysis. And that analysis has to be done on the basis of some predefined level of significance. Okay, so I'm fixing my level of significance at 5%. If 5% is my level of significance, remember, my corresponding confidence limit is 95%. Because level of significance is actually a kind of probability of accepting, rejecting a true null hypothesis. That is called the level of significance. About that thing I'll discuss later on. But today, in today's class, I'm actually focusing on the problem part. So 95% is the region for which it is called the acceptance region. It is the region in which I'm actually I will actually try to accept the null hypothesis. And with this probability 5%, we shall try to reject the null hypothesis. So since mod Z is coming out to be less than 3, so actually I know that in this particular scenario, the value is in the acceptance region. So we shall go for step number 3. Since my predefined level of significance is fixed at 5%, so we will say that since the test is two-tailed. Why it is two-tailed? Because in so far as I can remember, in the null hypothesis section, equality symbol was there, and in the alternative hypothesis section, not equal to symbol was there. So the test is two-tailed, and as the level of significance, I think I need to write it in short. Level of significance. Let us call it LOS, because most of the time I have to use this word. So since my LOS is 5%, and we know by the rule that mod Z is 2.53, which is actually greater than 1.96, which is the value at 5% level of significance, at 5% LOS. So what we find? We find that this value is greater than 1.96, and this concludes that the null hypothesis. What was the null hypothesis? That the rice eaters and wheat eaters are equally probable. That proportion of rice eating people and wheat eating people, they are same, half. That hypothesis is actually not true. So I wrote it as population proportion to be P is equal to 0.5. And this was my null hypothesis. This hypothesis is false, because false at what? False at 5% level of significance. Okay, but if we try to, if our predefined level of significance is 1%, suppose I am fixing my level of significance at 1%, that means my confidence limit is 99%. So in this scenario, the same problem gives you a different result. We find that if I call it step number 3A, then let us call it as step number 3B. Since the test is two-tailed and LOS is 1%, we see that mod Z, which is 2.53, is less than 2.58. Okay, and therefore H0 P is equal to 0.5 is accepted at 1% level of significance. It's a very strange result, as you can see over here, that the same problem which is accepted at 1% at one particular percentage of level of significance, but rejected at another particular percentage of level of significance. Here it is accepted and there it is rejected. So acceptance of a particular null hypothesis doesn't imply that it will be accepted throughout. For some region, it will be accepted, and for some other region, it may be rejected. That result you have to keep in mind. So originally the value was 3. Okay, and this was -3, and we saw that since mod Z is less than 3, so my value were lying somewhere in this area. Somewhere in this area, my value was lying. Now, later when I was fixing my level of significance, I fixed 5% level of significance. I was choosing 1.96, and here I was choosing -1.96. But at this stage, we have seen that the value was not lying inside this range. I started for looking at the value in here in this particular region, but I saw that here the values are not lying. Then I fixed my level of significance at 1%, and for that the lower limit is -2.58 and upper limit is +2.58. And then I'm sure that if I consider this as my acceptance region, then I can I can accept, there is a provision of acceptance of my null hypothesis. There is no chance that the null hypothesis will fall between minus 1.9, this probability will fall between minus 1.96 and plus 1.96. Okay, the range is becoming wider, but in this wider range, and which is this wider range, that is the closed interval minus 2.58 and plus 2.58 is obviously the subset of minus 3 and plus 3. But in this interval at 1% level of significance, we can see that our null hypothesis is getting accepted. So the main part of the discussion is that whenever we select or reject the null hypothesis, it depends upon the level of significance, the choice of the level of significance. What sort of question you may encounter in the examination? In the examination, you may encounter a question of the form that the acceptance and rejection of null hypothesis is independent of choice of level of significance. Is this statement true or false? It is independent of level of the acceptance and rejection is independent of level of significance. Choice of level of significance is actually false, because it is pretty much dependent, because depending upon our choice of the level of significance, sometimes it is getting rejected and sometimes it is getting accepted. So if you can recall this particular problem, then you will be able to give the correct answer to the given question. So with this, I'm actually concluding my previous incomplete question. Now I'm going to get into a new case. That case has not yet been discussed in any class. This is my case 3. My case 2 was the test of significance of single mean. Right now I'm going to discuss another case, which is test of significance of difference of population proportion. This is my test. Okay, so as you can see, this word difference of population proportion is there. That means what? That means this time we are actually going to take into consider two populations. One is population 1 and another is population 2. This population 1 will have some kind of population proportion P1, and this population 2 will have some kind of population proportion P2, and I am interested in finding something on the basis of this difference of proportion. So your test statistic will definitely change over here. Okay, we need another formula, another test statistic in this case. This is also in the domain of large sample test. I'm actually considering the large sample. It's where the sample size is more than 30. Okay, n is greater than 30 is being considered. Remember. So my today's question is random samples of 400 men and 600 women were asked whether they would like to have a flyover near their residence. Okay, 200 men and 325 women were in favor of the proposal. Test the hypothesis that proportions of men and women in favor of the proposal are same against that they are not at 5% level of significance. If nothing is mentioned about the level of significance about this choice, then you can select any one of these two. Rather, if you ask me about my choice, if nothing is mentioned, then what I do, I try to test the hypothesis on the basis of both the existing level of significances. Because you will already know from our previous example that our acceptance and rejection of the null hypothesis is pretty much dependent on that. So if I am accepting the null hypothesis at 5% level of significance, I need to check whether it is being accepted at the other level of significance and not. But anyways, if you carefully look at the problem, you have definitely understood that by the previous two formulae that we have used in case 1 and case 2, this formulae will not be applicable over here. So in this case, we need to have some different kinds of expectation of the random variable and variance of the random variable. Keep in mind that since we are actually doing the normal test, all these tests are falling in the category of normal test. So the general standardized version of the formula is this one. What actually is being done over here at different points and in different cases, the version of Ex and standard error of X is getting changed. Now here in place of X, what we are actually interested about, we know that if capital P1 is the population proportion, okay, population proportion cannot be calculated directly, but this can be estimated by, it is a well-known fact, this population proportion can be estimated by the sample proportion, small p1, selected from the first sample. And similarly, P2, this population proportion can be estimated by sample proportion selected from the second sample, isn't it? So definitely small p1 minus small p2 definitely will estimate the difference of population proportion, that is p1 minus p2. So in place of X, I'm going to write the variable small p1 minus small p2, which is the sample proportion, difference of the sample proportion. And in place of Ex, I'm going to write the difference of the population proportion, p1 minus p2. And the standard error of X will be the standard error of small p1 minus small p2. I'm going to give you the explicit representation of this particular formula in the next page. Please take the screenshot of this page because I'm moving very fast. And do not waste your time by writing all the questions. You just take the screenshot. Later you copy it in your maths copy. Okay. Now, first of all, according to the, now I'm coming to the solution part. First of all, we need to define the null hypothesis. In null hypothesis, what is being written over here? It is written that we need to test the hypothesis that proportions of men and women in favor of the proposal are same. Okay, against that they are not. So we will write that let there be no significant difference between the population proportions capital P1 and capital P2. Capital P1 is the population proportion of men in favor. P2 is the population in favor in the first samples. First sample is this in the first population, not sample, in the first population in favor in the first population. First population, I'm considering first population is the population of men. P2 is the population proportion of women in favor in the second population. So So these are the population, these are the definition of population proportion with respect to my problem. Consequently, Q1 will definitely be 1 minus capital P1, and Q2 is definitely going to be 1 minus capital P2. And you know what are the meanings of Q1 and Q2. When I am writing that there is no significant difference between the population proportion, then it means that I'm considering capital P1 and capital P2, they are same. Why? Because it is written, we need to test the hypothesis that proportion of men and women in favor are same. So we are considering this P1 equals to P2. And since H1 is the complementary hypothesis to null hypothesis, so definitely this is going to be capital P1 not equals to capital P2. But carefully observe the formula that we wrote in the previous case, previous page was like this. The formula was small p1 minus small p2 minus capital P1 minus capital P2 by standard error of small p1 minus small p2. But whenever we actually assume this particular part, that is capital P1 and capital P2 are same, and we test the hypothesis on the basis of the choice of the null hypothesis, then under the null hypothesis, under H0, my test statistic, the test statistic becomes, my test statistic becomes Z is equal to small p1 minus small p2 by standard error of small p1 minus small p2, simply because this part will vanish. P1 minus, since P1 minus P2 will vanish because of this choice. We need to know the form of the standard error of P1 minus P2, and this formula is, I'm writing on the right hand side. The reduction of the formula is not needed. I'm not going into the details. It will just kill the time unnecessarily, but I'm providing you the formula. In this case, this is going to be capital P cap, capital Q cap, 1 by N1 plus 1 by N2. Okay, what is this? Capital P cap is the estimated value of population proportion, and capital Q cap is 1 minus capital P cap. I'm not writing P1 and Q1, remember. And N1 is the size of first sample, N2 is the size of second sample. Okay, so we have got all our meanings of the notations. So we are going to implement this over here. And by the by, what is small p1? Small p1 is the sample proportion of the first sample, and this is nothing but capital X1 by N1. Capital X1 is the random variable in the first sample. Small p2 similarly is the random variable in the second sample. So in place of small p1, we can write it as X1 by N1. In place of small p2, we can write it by X2 by N2. And in place of this, we can write it as capital P cap, capital Q cap, 1 by N1 plus 1 by N2. So we can, if we can find out all these values, then our job is done. We are going to find it now. Only one problem is there existing. This can easily be, the numerator part X1 by N1 can easily be calculated. X2 by N2 can easily be calculated. Only problem with this one and that one, because population proportion is actually cannot be calculated. So how can I find capital P cap? If I can find capital P cap, capital Q cap is matter of second. Since P cap is not known, since P cap, sorry, not P cap, since P is not known, so we can estimate P cap by the following. We can write it as in two ways. We can write it as N1 P1 into N2 P2 by N1 plus N2. or we can write it as x1 plus x2 by n1 plus n2. Okay. So by this we can estimate p cap. So this is done. Now we'll try to find out whether the values are given in the question. What values are given in the question? In the question, it is given random samples of 400 men. Okay, so my population is 400. My population is men. First population I'm considering as my population of men, and from there I'm selecting a sample of 400. So n1 is 400. My n2 is 600. Is the sample of women chosen from the second population. X1, what is written? 200 men are in favor of the proposal. So 200 men are in favor of the proposal. So I'm writing X1 as 200 and X2 is 325 women are in favor of the proposal. So we have got all our values. Now, rest is your duty is to find this P cap. After this, you find Q cap. You don't need to tell me the values individually. Find it, find small p1, find small p2. Small p1 is given by this formula, small p2 is given by this formula, and you know n1 and n2. N1 and n2 is also known. After calculating all these, substitute all of them in the formula of Z, which I'm writing over here once again. So quickly calculate this probability, this value of Z, and write in the chat box. Hurry. You calculate the value and write in the chat box. Anybody, please do it first. Shivam Kumar Singh, Anurag, Nasal, Utkarsh, anyone, please respond. Nikita, what is this value? Nasal has got minus 0.0575. Is it? I mean, I want to verify with somebody else. I don't know. I've chosen the problem from the exercise, and I can see the question, the answer is not given. So somebody else, please check. Otherwise, I have to deal with minus 0.0575. I have to consider this value. Others, please, anybody else, at least one person, please check, because most of the time we have seen that your answers are not matching. If Aniket is present, Aniket can also write his answer. Shomilia also can do this. Anybody, please, anyone else, whether you are getting this value or not. I just want to verify. This value which Nasal has got, at least I can say that the value is negative. Okay, so now right now probably you are understanding why do we need to take into consideration this absolute value of Z. So we need to take the value of this negative number, and then the positive side will come out. So if my normal curve is like this, I'm actually giving my conclusion on the basis of the positive side. Okay, so that's why I consider the this particular positive part. And this step 2 will tell us that mod Z according to this calculation is pretty much less than 3. So obviously further analysis is necessary. Further analysis is required. And since in step 3, since my level of significance is fixed at 5%, and we see that mod Z is less than 1.96, we are going to accept H0, and we conclude that proportions of men and women in favor of the proposal, they are same. Proportions of men and women in favor of the proposal are same. That will be the conclusion according to the Nasal-Manit's calculation. I just want to verify whether this calculation is all right or not. Okay, so nobody is responding. So what can I do? I do not have the time to take the calculator and do the calculation for you. I'm going to write a second problem from this particular case only. In a large city, capital A, 20% of a random sample of 900 school children had defective eyesight. Okay. In other large city B, 15% of random sample of 1600 children had same defect. Is this difference between the two proportions significant? Obtain 95% confidence limit for the difference in the population proportion. Obviously, this particular problem is falling into the category of case 3. Okay, so we can deal with this particular problem by the previous test statistic. But if you are going to reject the null hypothesis, then we need to find the 95% confidence limit of the population proportion. I'm going to write that part of formula only. According to our previous experience, this limit can be found as, since it is 95% confidence limit, it would be multiplied by 1.96 and then by standard error of small p1 minus small p2. And not only this, there is another change in this particular problem. You can do one thing. Yeah, small p1 can be calculated, small p2 can be calculated, and standard error of small p1 minus small p2 can also be calculated. Everything can be calculated pretty well. So I think you will not be able to, you'll not face any problem in finding the confidence limit. So all these sections has already been done. Try this particular problem. Nobody has responded. I have noticed nobody has responded to my problem of flyover. Okay, you all are depending upon what Nasal has got. Anyways, if Nasal has got the wrong answer, you just have the wrong answer with you. You are not calculating. That is very heartbreaking, I can say. Nowadays, every mobile has a calculator. At least you could do the calculation. Check it, whether the value is correct or wrong. We shall meet in the next session.